behind Jyrki, there's a fridge and there's some more beer and other refreshments. And what else? Oh yeah, empty cans. There's at least one bag behind Jyrki also at the big wooden table. And if you have any trash, there's 2 trash cans over there. Just put it there. And yeah, and if you have any empty plates, just put them in the kitchen, which is over there. And also, when you leave, use the button on the door downstairs, because if you use the like mechanical lock, it will actually trigger the alarm. So it would be nice if you just press the button. And yeah, thanks for coming. And if you are interested in software development or hardware development, come work for Wapice. And yeah, thank you.
One little thing, some of you may have noticed, we have these awesome one-of-a-kind Web Dev and Sausages stickers to put on the back of your computer. Don't take like 10 of them, obviously. We'll have enough for everybody as long as there's no hogs. But yeah, there's like a little pole dancer at the bottom. They're super cool. So take one of those, please. We're going to start the presentations around 7. So yeah, enjoy yourselves until then. We're going to start like maybe in 5 minutes. Is that okay? Yeah, it looks like you're ready to listen. Are presenters ready, though? That's like a crucial question. You guys are ready. Where's our first presenter? Okay, we'll find the first presenter and then we'll go. So pretty soon. All right. Can we turn the music down, please? All right. Is everybody comfortable? If you want to sit somewhere else to listen, now would be a good time. So welcome. This is the fourth Web Dev and Sausages. And we want, before we begin, again, to thank our sponsor, who basically does all of this, provided the food and the space and everything. In this case, they actually came to us, and we're just so thankful that they were interested to sponsor Web Dev and Sausages. So thanks again, Wapice, for your support. And let's get the show on the road. So our first presenter is ready to talk about microservices. So Jaakko, I'll turn it over to you. You got everything set up? Yeah. All right.
Hello, hello. Can you hear me? 1, 2. Okay. So, yes. Okay, so hello, hello. I'm Jaakko Takaluoma, 42 years old, very soon, from Wapice Oy Ltd. I'm from Vaasa. You know the place, the sunniest city in Finland. I think there was something like 3 sunny days during this summer. I don't know. My current position is this lead architect in business solution segment. My background is in multi-user transaction systems. I started 98, I think, 97, something like that, in Helsinki area with insurance business and finance business. But now I'm working for Wapice from 2005. My line of business is industry and manufacturing and things like that. My hobbies are simply fixing things, mostly mechanical things. Then I do fishing and judo, but no computer-related hobbies. No. Okay, this presentation, microservice success story, it says. I try to open somehow Wapice experiences, which are mainly positive, about microservice architecture in context of our flagship product, IoT Ticket. We did some renovation of the software architecture for that particular product during 2015-16. Even this year we did something, yeah. Developer perspective is included. I am basically part of the team that implements this and designs this whole thing. So I had my hands in the clay. Okay. How many of you have been working with microservices? Hands up. Okay, 40%. Okay. Is it some kind of hype or what it is? I don't know. But they are really cool. How many of you have more than 10 years of experience in IT business? 25%, okay. I have really good eye on these percentages. So, have you ever seen the golden era of Java EE? Have you been implementing systems with Java EE? Full stack. Okay. Okay, let's go. I just want to know some background because maybe I can adjust my talk somehow. I don't know. The product is the most comprehensive IoT product in the market today. It is the office suite of IoT. And if you don't believe this, you can ask for a demo or register and try it yourself. How many of you know what IoT is? really know. Heard is different thing. Okay, but go there and connect your things there, so you know. That's about marketing. But I am here. So technically speaking, the system is a cloud-enabled software. It scales, and it's designed to store enormous amounts of data. That's to be proven, of course, but it should be. And this picture here, I'm not going to zoom in. This is just marketing. There's these balls and, you know, rectangles. You can see all kinds of stuff there. But really, we have databases, SQL databases, and NoSQL databases. I think that SQL databases, they are the best because they are, you know, they have all the features. And nowadays they can even store enormous amounts of data, which was not necessarily possible a couple of years ago or something. Then we have message queues, and then we have streams. And by streams I mean stream processing, this kind of stream batch processing, Spark, Storm. You have heard about them probably. Then we have plenty of REST APIs, and we have Java components. Our backend is Java-based. Then we have this SPA, kylpylä-sovellus. So we have those JavaScript, HTML5, things like that. And then, of course, we have infrastructure to run these components. Okay, the history of this software case is more than 10 years old. And 2005, this monolithic application server-based architecture, it was considered really top design. So, and I knew that Java EE really well. I had learned it from the previous life. So I think I tried to do all the things, the best practices that I knew, including layered modular architecture and EJB session facades, and I tried to utilize the application server resources really well and so on. And it was really good. We managed to build the system. But still, a couple of years ago, 2014, we decided to start to move, you know, existing software product, change the architecture quite fundamentally from monolithic to microservices. This next picture here is, it's not stolen, it's borrowed from Martin Fowler. He's some kind of evangelist of microservice architecture. This is really good picture. Here on the left you can see monolith, and here is the microservice. And I like these colorful blobs. They are the services. So if you want to scale your app, or first of all, you put your services in one big application, or maybe not application, but this kind of container. And if you want to scale, then you add one more node, and you put a replica or what is it now, cluster node, another agent running the same software on another host. But as you can see, the difference with microservice architecture, we are actually running these services as individual processes or something like that. But typically processes, at least we are doing it so, or Docker containers or something. But you can see that we don't want to scale this pink dog bone. But here we have to. It's running here 4 times. It could easily be so that this is actually consuming a lot of resources, memory or something. So why would we want to have it 4 times if we can only have it once, like with the microservice architecture? On the other hand, it seems to be that this orange bean like figure is scaled 5 times, but we only have 4 hosts in the monolith architecture. So here we win again. Yep. Okay. Monolithic architecture. Something about it. So it's very difficult to scale applications efficiently. The reason why I'm talking about this is because we moved from this monolith architecture. We invested money on moving our software product to new architecture, and we had reason. It was really difficult to scale, as you saw in the previous image. And then our customers started to talk about cloud. I don't know, is there somebody working for industry line of business? Some. You probably know it already that actually in industry we can use the latest technologies. We can typically use them really fast when they appear, because the projects might be really small and the customer organization might be willing to trust to the provider more than perhaps in insurance industry or finance business or commercial, what is it, kaupan ala. Maybe they know more about the systems and they want to, or I don't know if they know, but they at least don't necessarily trust the provider so much. But our customers, they are really willing to put stuff in the cloud. But with this monolithic architecture, it's really problematic, because how would you put Wildfly or JBoss running in Azure without using virtual machines? It's not very easy. But yeah, then eventually developers were not happy with the Java EE stack anymore, because the system grew. It was too heavy to be able to debug. You cannot really debug the system anymore. And I don't know how many software project modules we have in our IoT ticket product, but tens of them anyhow. But if you are using, for example, Eclipse, which is probably the case with many people, the amount of projects is so big that you cannot run the whole, you cannot load the whole software there in your IDE. But you have to do it if you want to deploy to your development environment, if you are a server developer. So you need to buy the fastest computer you can get with most memory, 64 gigabytes or something. So people do, typically they go where the fence is the lowest. So the web UI developers, they didn't even want to start this backend anymore because it's too heavy. Okay, we invented Vagrant box, easy to set up, but still it's consuming the resources. And still, if you are developing your web software, web application with AngularJS or whatever JavaScript framework, you have the REST API. If you only see the API, but you don't see how it has been implemented, it's a problem. Because then you stay web developer, you don't see to the other side of the wall or something. So it's a bad thing. But this microservice architecture, of course there's a lot of benefits. Well, there's benefits with monolithic architecture also, but I'm not going there now. But microservice architecture benefits, clearly the cloud support is excellent at the moment, because many of these cloud providers, Azure, Amazon, Heroku, maybe your own cloud, they quite easily support running small processes, command line processes, like Spring Boot applications, for example. You just start it, give the port number where it starts to listen, and then it's there. Quite easy to construct this kind of ecosystem where you run multiple microservices. How many of you have been using this cloud microservice support? Yeah, it's interesting. But it will be more. That was something like 7%. Okay. Clearly, these small service components, they are easier to develop and debug because you don't have to have all the big chunk of code in your Eclipse IDE. You only need your one microservice serving the REST API. Maybe a couple of utility projects. It's much easier, faster. Anyhow, you need to restart Eclipse. So now it takes only a couple of, let's say, minutes, but it used to take a couple of lunch breaks. Then one important thing is that developers, they don't necessarily want to be categorized as UI developers or server-side developers. There might be even teams based on this kind of discrimination. But you want to be, I don't know if all of you want to be, but most probably want to be. How many of you want to be full stack developers? 50%, okay. It actually happened that developers cannot fix bugs at the other side of the wall. If I'm UI developer, I cannot go and fix these bugs. And also, because I never saw the code, I only saw the REST API. And then when people start to use this common development server, where we have the latest version of the development API, it's problematic because this development server, quite soon, it becomes a production for the developers. Somebody wants to have some new feature there, and then it breaks something else. So this common development server idea, it doesn't work. At least if you don't have to do it like that. Anyhow, this all is frustrating and waste of human resources. So with microservice architecture, the developer starts only the minimum set of services and runs only the interesting services in IDE with debugger. And that really happens. I actually asked from our developers, is it true what I'm writing here? It is. So this is not a fairy tale. Yep. But now, because people can run the whole software stack on their development laptops, they start to understand the system as a whole, and it helps. It's really good. Okay. My final slide. Some kind of results. So I'm not talking about how we changed monolithic architecture to microservice architecture, or in details, but we did it. It was actually quite easy because we had used Java EE quite the standard way. We didn't use Spring framework. We used only Java EE, and we did it really disciplined way. So it was quite easy to change. It took some time, but we have been able to run the new architecture for almost a year, or actually more, but in production-like environment for a year about. And the good things, the system is much more stable. We didn't change the functionality or the services or anything like that, but because quite often, if you have big system, Java EE application, if something fails in the system, the whole application server can even come down, and it happens. So if there's some small one user manages to tickle some bug, so the whole system is down, and then it's a problem. But now it's quite possible that this stability is because now if this bug is found by one single user, only that particular instance of microservice is going down, and the others don't even notice. And it's really clear difference between the old and the new one. And okay, we have been able to fix these problems in the system behind the scenes without users noticing. I'm not saying that we have 100% rolling updates, but we are going there, and we have managed to do things really nice. Because with microservices we can put the new versions there, move the users there, and then get rid of the old versions, which is rolling update basically. Okay, then of course we wanted to try immediately scaling these components, like in the blob picture from Martin Fowler. So we have done that. We try to use the resources as efficiently as possible. And we have tested that sometimes when we have high load, we add more by clicking this green button more. And we have this cloud management framework in our own production system where we have this green button for more particular microservice and then red button if you want to lower the amount. And it works real time. Then this developer thing, we have clearly seen that we have been able to get younger developers produce better quality than before. And it is somehow because if you directly come from the school to work, then you are not experienced, probably. So it might be pretty difficult for you to set up this monolith to your computer and start to become full stack developer. But now you have to only have this small amount of code, basically. It's not so frightening. And we have seen that it's really good stuff. Young people can start generating good stuff really fast. And developers are happier in general. At least the server-side developers, because they are not the 2 guys anymore, but it's like 7 guys now. Less work. I tried to figure out some kind of challenges. Of course, there are a lot of challenges with this kind of architecture. The system setup is much more complex. But somehow, when you solve it once, then and learn how to do it, it's not a problem. There's some kind of learning curve when you're running the, I call it microservice zoo. All kinds of different animals running in the microservice zoo. But when you get it running, it's actually quite smooth. And then you might have some challenges with logging and metrics. But there are frameworks for that. You have to just think a bit differently and probably consume some effort to get logging and metrics. Yeah. Okay, but this was last slide, something like 30 minutes. Now you can ask.
Any questions? Here's the microphone.
I don't know if I can answer, but I try.
Like, we are basically also working with very modular system, and we are just using some scripts for setting everything up. So what are you using to setting everything up in your dev environment?
Our product is, and the customers, they are such that some of them want to buy this product and install them in their own cloud environment. So we have really different ways to set it up. From the beginning, we have been basically we can run it manually, which is not a good idea. Then we can run it in Amazon using certain beanstalk features and things like that. There you have automation done in a specific way. But our own production, we are actually relying on HashiCorp products, Nomad, Consul, things like that. So it's automatic cluster management. Then we are using, of course, the quality side of things. Jenkins we are using. We are doing the builds from Jenkins and managing the packets to Nexus and Docker repositories directly from there. And it's like I said, it's complicated. But when you have it done, then it's and the new version goes there in the production. Do you believe it? You better
We
believe
are
it.
trying to set up the Docker, to deploy easily. So, but of course it's
Our microservices are, I can say that much without revealing any secrets. We are, like I said, we are using Java. We are using Spring Boot. Do you know Spring Boot? Hands up. Spring Boot. Okay, good. 70%. It was a good technology selection then. Okay, any other questions?
Okay, so with new architectures typically come new classes of bugs. So have you encountered any kinds of bugs with microservices that you wouldn't encounter in a monolithic application? For example, related to synchronization or timing or network issues or anything like that?
I believe that network issues might be one, but we don't have them. I mean, we haven't seen any problems with, like for example, Netflix of course has, but they have, let's say, some more nodes in the cluster compared to us. But memory issues. And because, okay, like I said in the beginning, we used Java EE. All of our code has been stateless from the beginning. So maybe you can draw some conclusion. It was quite easy to change to microservices. But still we have had some memory problems. But I don't know if they're bugs or something, but we had to do some things a bit differently. But no, not really. To your question, we haven't found any, at least I don't know any family of bugs that
Since
appeared.
when you're dividing your software into separate services, you're basically introducing parallelism, and you may encounter bugs that come from, say, getting some information from one server's service.
Yeah, actually, one thing.
So on.
One thing that you now I remember. It's not a bug, but it's a feature. Of course, there's a level how much micro you want to go. We didn't want to break the whole thing so that really narrow services are their own microservices. We don't have so many microservices, but we wanted to split the system to such microservices that need to be scaled. So basically, one thing is challenging that, or different, is that if you have application server, you have the database connection pools. So you can specify 250 connections. But now if you have 10 microservices, you cannot say to all of them that you have 250 database connections. So it's not a bug, but you have to think somehow, you have to adjust the pools, threads, things like that. They are configuration parameters, but you have to take some kind of ottaa kantaa, mikä se on? Well, anyhow, you have to ottaa kantaa to this consider, something like that. You have to consider this resource optimization.
Okay, thanks. That's what I was after.
Yeah, so I was wondering, you did answer maybe little already, but how small you went with services? Did you split some services into stateless functions, like using some serverless architecture? Because I'm wondering, that's next step from going monolith to micro architecture, and then to split even more and get more efficient and less waste.
Somehow, if you are building Java EE applications, it's not a big application, but it's actually a group of modules. You have these EJB applications, and you have some web applications. Actually, it is already somehow microservices, but you just have to run it in a monolith. So we didn't split these Java EE application modules into pieces, but we broke the whole enterprise application into microservices. So we didn't split too much. We didn't have to. And if you are doing something like that, you shouldn't either, I think. Or why would you split if you don't have to? We didn't do this just because we wanted to be state of the art or in fashion. We did it because of something I tried to explain here. Developers were not happy and we couldn't scale and things like that. But I don't know if I answered, but it was an answer. Yeah.
Okay, thank you very much, Jaakko.
Thank you.
And we always like to appreciate our speakers, so you get this incredible Web Dev and Sausages hat to protect you from the sun in Vaasa. Let me give you a little advice. So I'm from LA. So like if you want to hang back and be loose, you put it on backwards. And if you're conservative, maybe a Java EE guy, then you wear it like this.
Whatever comes my bowl.
Okay. Yeah. All right. So we're going to climb over the wall. I like the metaphor of the wall. We're climbing over the wall to the front end now. And I'd like to invite our next speakers, so Fabiano and Andre. These guys came all the way from Helsinki to present to us. And I'm going to turn it over to them. Yeah, we'll like, while they're setting up, a good chance to run to the toilet, get the last beer out of the fridge. So a couple of minutes. By the way, don't forget about we have this quiz coming after the last talk. This cool pub quizzy quiz. So like immediately get your team together as soon as the last talk is over. Like be thinking about, okay, I'm going to grab that person and I'm going to be a team.
Are you gonna present together, or is some of you gonna?
Him first and me.
Okay, then maybe you can take this one, and the other one takes the microphone.
Yeah, fair enough. What do you mean? That way is fine.
Hello, hello. Yes, this works. So welcome. My name is Fabiano, and here we have André. We're going to present this together because, let's say it's a little bit tricky subject. We bumped into Polymer in the beginning of this year, and actually the name of the presentation came out as a joke, and it became a real thing here. So yeah, let's talk about Polymer then, because I'm going to start already saying that we didn't have a good experience working with Polymer. Who has worked with Polymer before, tried something like 5%, maybe? So yeah, you can see how already reflecting here the numbers. We're going to show some numbers. And we work for lead-in/go-for, slowly becoming only go-for. And to start with, what is Polymer? So Polymer, it was a library for creating custom elements that, well, they behave like standard DOM elements. They were created by Google in 2015, right? Or I think the 1.0 came out in 2015. Maybe it started around 2013, if I'm not mistaken. And basically, just to mention a few features, or yeah, let's call it features. The elements can be instantiated using constructor, or you can use just document create element. So that's nothing new about that. You can configure using attributes or properties. If you guys have worked already with component-based architecture, also it's nothing new. They populate the internal DOM with the internal DOM inside each instance. So it has a really self-contained DOM. And DOM is a funny thing. It was one of the first funny things I saw about Polymer, that you are used to work with the DOM. And then if you work with React, you might have seen the virtual DOM. And then when you bump into Polymer, you see that there is the real DOM, there is the light DOM, shadow DOM, shady DOM, funky DOM, no, not that one. It becomes a little bit complicated. It's responsive to property and attribute changes, so there's data binding happening there. Styled with internal defaults or externally, so you can expose style to the parent, so the parent will pass variables to style a child component, for example. And responsive to methods that manipulate its internal state. What was that about again? Oh yeah, it works. It works. Let's say pretty much like jQuery. You call the element, and you just call the child method inside the element. So, and why Polymer? So, as I said in the beginning, this is a very biased presentation based on real life experiences. So we had this experience starting about in February. We're still working for that. It was a project for a client. We might be able to show some lines of code also. There's going to be some lines of code here. I know you guys have been coding the whole day, but hold on. And what's good that we could notice about Polymer is that it creates really custom reusable components. So there's the webcomponent.org. People create components, share the components there. You just can download, use them, import and use them. And well, they can be easily packed and distributed. That's pretty much related to the first one. And not so good that we could observe is that create deep interactions between components. And actually, this can be a problem in a misuse in component-based architecture. So we saw some components, like we would try to find a bug in a specific component, then when we would see, we would be like in the 80th, 90th level, you know, inside of one component, inside another, inside another, inside another. And that's horrible. It's not so good for creating whole web applications. So I would say that it's more like a component library than an application library. So if you want to create an application, Angular is perfect for that. React is perfect for that. And this is good maybe for very simple stateless components. And Bower is mandatory. So we see that Bower, like people are using more NPM. There's now Yarn for managing packages, and they require you to use Bower. You can install Polymer actually, there's something that you can install with npm in the beginning, but then if you want to install Polymer and all the elements that come along with Polymer, you have to use Bower. So, and Polymer components can be mixed with other libraries. So if you want to use a Polymer component inside an Angular React application, you can do that. But should you? As you already have Angular, you are working with React, why would you mix up? And well, when we came across Polymer in the beginning of the year, we asked ourselves, why Polymer? Why indeed? And because there was all that buzz around Angular 4, also that Angular would release the CLI and everything, and we thought, okay, Google is putting a lot of effort in Angular, so why are they talking about Polymer? And they were already talking about releasing the version 2 of Polymer, and we checked a little bit the pages that are using Polymer, and it's mainly Google using, like they're using themselves Polymer. And well, big applications, big companies, they have been using React and Angular all the time. And we decided to get some numbers to compare. And I think this reflects quite well the state. So we got stars force contributors and on GitHub. Then there's the builtwith.com. It tells you what's the percentage of websites built with that tool, or the top 10,000 websites on the web. I don't know what's the criteria for the top 10,000. Issues on GitHub as well, and then threads and Stack Overflow. Well, it's the, let's say, I don't want to say that, but less appreciated, if you think about the stars. On GitHub, last number of forks. Well, there's Vue.js also, that's pretty new, and you can see already that's a bunch of people liking and using. Very small community, 120 contributors compared to 2,000 from React. And here it's AngularJS and Angular together, the numbers. Built with the number here, it's mainly because of AngularJS. And Vue just came out and already passed Polymer. Number of issues, there is plenty of issues in Angular, but I believe that it's pretty much because of these the problems they had launching Angular 2. What else? Threads that could reflect. Some people say that the number of threads could reflect the number of issues that you have, but it also reflects the number of the size of the community. So if you have an issue, you have to go look for something in Stack Overflow. It's much easier to find for those frameworks than it is for Polymer, right? So a little bit of code now. Components declaration, and again, we're talking about Polymer 1 here. We didn't try Polymer 2. Yeah. We don't say that. Sorry. And basically, you declare a DOM module. And first weird thing we notice about that, it's an HTML component. So you import an HTML. It's everything in the HTML. Of course, you can build in separate files and then bundle in the end. But the result is an HTML file. It's an HTML component. And then you have this template declaration with this style inside. And the script is that the way you declare a Polymer component in the script. So there is this kind of a repetition in the idea of the DOM module and also in the script. And also you declare properties just like that. So it's just a huge object that you have all the properties and methods just below each other. And that's okay, it works. So yeah, there's property typing. Even though the project we have worked with, they use TypeScript also with Polymer. That's okay. It's that's a good thing actually to have types. And supposed to put everything in the distributable HTML, as I said. About data binding, it offers you the possibility to have one-way and two-way data binding using different notations. So double curly braces, or double curly brackets for two-way binding, and double square braces for the one-way data binding. We learned how to call that a double mustache, the two-way data binding. So nothing special to say about that. You probably, if you work with Angular, you know really well how it works two-way data binding. React, you know also the one-way data binding. And Polymer offers you the possibility to work with both. There is the scope to styling I mentioned. So you can do like this. Let's say you're creating a toolbar, custom toolbar. Then you can expose a variable, let's say the color of the title of your toolbar, and put a default there. And then your parent component, you just define the color that you want your toolbar to be. So host means the self component. All toolbars are supposed to be green unless you have another class there. So those two are green, and those that you have the warning class is going to be red. So you access the style inside the components that way. And now André is going to continue for you.
Little. Well, moving on from that, so every component makes available a bunch of life cycle methods like these. So for every method, you have actually some control on what's happening during its life cycle. So first is the the created function, which is like as soon as the component is created, but it's just like, well, it's basically like when the script is instantiated. Then you have ready when the local, and I emphasize here, local DOM is initialized. So you already have access to the component's own DOM elements, but not within context. So if for some reason your component has to interact with something outside of its own local DOM, then you don't have it yet. That will be the attached function. So, and this is the point that you can get your code to interact with the actual DOM. Then you have the detach function if you want to run some specific stuff when you get rid of that particular instance. And last of all, you have the attribute change. So if you change any properties in your component, you can actually you can use. I mean, if it's a very simple component, this makes a lot of sense that you can just use a single function and then handle the name and type of the attributes that are changing here. But as I'm going to show you soon, there's actually better ways of doing that. Observers are perhaps like the blessing and the curse of what we've seen in Polymer so far. So you can create basically two kinds of observers for properties in Polymer. So for example, we have here like a disabled and a highlight properties. Then we have observers for them. So this implies that disabled changed it's an observer of disabled itself and so on. And then this actually, I mean, behind the curtains, it will handle a bunch of listeners for you, so you can actually have something react to a piece of changing property. However, this can, I mean, there's one interesting thing about this is that Polymer gives you the guarantee that this is going to be handled in a synchronous manner as long as you use the this.set property function. So if you do this, you have the guarantee that all observers that are pending are going to be executed before the next line of code, which is of course very nice. On the other hand, if you as you use these this.set functions like in chain, like we have here. So for example, when you change the disabled property, then you set the highlight property, which will trigger the highlight changed observer. So you can. Quite often it happens that you fall into an infinite loop or something that is quite hard to track, but still, it's something that's nice to have. Then you have complex observers, so you can declare an observer outside of the scope of the properties themselves, and then you can actually list a bunch of stuff that you would like to observe. So maybe, like I have I have done, I mean, a couple of days ago, like I would have to observe some date and time components on screen, not components, sorry, but properties on that the user might change, so I could do a lot of data handling, and so I would like the same piece of code to observe both, so I could use like an observer to date and time. And then you can do some deeper stuff, like here you have user.name.star, so whatever objects you have within the name whatever properties you have within the name object, then you can observe those. Then you get a somewhat different observer that you can actually evaluate which path under star is changing, and then you can handle the value like that. So you can do some pretty deep stuff, but as you chain observers together, you can mess up like really easily. So it's something to be mindful of. What else? Oh yeah, I accidentally already covered multiple attributes, so you can have one single observer observing a bunch of properties at once. You can also have specific observer behaviors for arrays. Then you have to use Polymer's own functions for manipulating the arrays if you want to make sure that the observers will run properly. What else? Computed properties. They're like somewhat like equivalent to the virtual, what would you call, virtual properties on when you're dealing with Mongo, for example, Mongoose in that sense. So you can have like this is not a real property that is going to be. It's just a consequence. So this is a property that implies the running of a function. So actually, full name is a function of first and last name, so this will in turn observe that. So every time that first or last name change, you will get a change to this thing. So, and these are read-only, by the way, because of course they can't be otherwise. What else? Then behaviors are another nice feature of Polymer. So you can code like common behaviors so you can attach them to different kinds of components. So, for example, I can have maybe plenty of UI elements that can be highlighted in a specific situation. So I code a highlight behavior, and then when I declare my new component, I just say, okay, this has highlight behavior. So from this point on, all code will well, for lack of a better word, inherit the highlight behavior into itself. So I mean, this will behave as the highlight behavior and as any other behaviors that you attach to it. Okay, so this is our last slide. So this is more of an opinion-based stuff. As Fabiano said in the beginning, this is a very biased presentation. So while we covered a bunch of technical stuff here, Polymer does like plenty of stuff that other libraries and other frameworks do. Just in a different manner. You have some nice features there, but I wouldn't say that Polymer is inherently bad, but it seems pointless right now. So why you have some pretty big applications, some pretty big stuff running with Polymer, like mostly Google stuff, of course. So like Google Play Music runs with Polymer. Do you have you presented that list at some point?
No, we can show that.
Where was it?
Oh, we can quickly open here and show.
So you have some high-profile stuff running on Polymer, but that's actually quite redundant. So the same work that can be done with Polymer can be done, for example, with React. And when the rest of the world is running React, why the fuck would you use Polymer? Right? So you have some libraries. Sorry, not some libraries. You have a whole bunch of components in web components. .org. But they're not as great as the kind of components that you see available for React and for Angular and so on. And of course, Google doesn't make their own stuff available easily. So while it's nice to have your own components like behaving like native DOM stuff, that's actually very nice. But it's just, I mean, it's not evolving properly. Just go back to the slides.
Yeah,
we can do
I can't find now.
Yeah, we can do that at some other point. Ooh, there we go.
You can even find that.
So the point is that there are better things out there, and Polymer hasn't been evolving like expected so far. So I don't really see a point. If I would, as it says here, so if we would start a new project right now, would we use Polymer? So it's just not worth the hassle. I mean, it's okay. It does what it does. There is some support, but not much support. If you have like a weird bug, if you need support from the community, you have a hard time finding that. There are not many people doing that. It's just at the wrong end of the evolutionary ladder of web libraries right now. What else? I think we covered it all. Yep, that's pretty much it. So you might have some questions, and we might have some answers. I'm not sure, so let's try this. Is this the only microphone? Yeah?
It would be nice to hear also if okay, cool. If you had also some good experiences with that, we would like to hear.
What I'm interested about, I mean, Angular and React are obviously pretty big, but you mentioned Vue already in the presentation. So can you compare Polymer and Vue?
Yeah, not really. I haven't tried Vue. We have one colleague here who have tried. Maybe you can talk later with him. But no, sorry, I haven't tried Vue. Just the numbers.
So I'm just interested in like, you chose Polymer for a project, I guess?
Yeah.
Or just tried, okay. So you've actually done a project now in Polymer. How screwed are you? Like, what's going on?
It was, we got this, we started this project and it was running already for 1 year, about 1 year. So we didn't start from scratch. And they have a, let's say, a peculiar combination using Polymer, and then the template is done in Jade. And then they use some, well, we saw the good side of microservices, but we have some misuse of microservices there as well. So yeah, that's pretty bad. But actually, we have showed the client a small prototype of one part of this application in React. We had some time to do a prototype. And something they took, I don't know, 3-4 months, we did in 2 weeks with React. And yeah, and they're thinking about still doing the version 2.0 now in React. So not that screwed.
Okay, couple of questions. Do you know the history behind Polymer, and have you used Polymer before 1.0?
The history, more or less, it's what I told you in the beginning. I don't have like details, but I think it was 2013 it started, and then version 1.
Before version 1, what it was originally supposed to be, since that sheds quite a bit of light on why it's made as it is and what's the point behind it, or actually what it was. Well, it was actually first a polyfill for web components, a kind of standard way built into browsers to create custom components, consisting of custom components, shadow DOM, templates, and what was it? Oh, yeah, HTML imports. And those were supposed to come into all browsers. But then different browsers started having troubles. Firefox, for example, still has troubles with shadow DOM. And then it never came. So you can actually see it, I think, still in Polymer in the platform.js, which is the original polyfill that brings all those features to any browser. And everything else was in the beginning just some sprinkling, something to do with those. But the point was being the polyfill. That's where the name comes from. And over time, as the browsers didn't implement everything needed, so they couldn't take the platform.js out, they started adding more and more. And at 1.0, which is when I stopped tracking Polymer, they went full on with the all the other stuff and pretty much gave up on trying to be an implementation for web components and just did their own thing. So that's when they screwed up.
Okay, that's good to know.
Okay.
Thanks. We have more facts, more facts.
Yeah, I have started experimenting with polymer. It was about 0.5, and then it was like some big changes, 0.8, 0.9 before 1.0.
Okay,
Yeah, you remember those. So in the end, of course, most of the developers were on Angular. React not so much because it was quite young at that time.
Yep.
But so they try to do too much. So basically they kind of break away from the original promise that okay, you should be able to add your own, like to extend the browser. Basically this is what a web component is. So they started with that. They went to some extent with that. There was big disagreement with the other browser vendors, yeah, like to, and in the end they had to compete with the features of the other, like Angular and React. But the story is not that bad because if I might be wrong, but except this Shadow DOM, which might not be like universal agreement on that. Now on the, like, if you take the evergreen browsers, all of them support web components. So if you, I think they do, or are they going to? But Safari.
Active development on HTML imports. Edge is still voting on few things, and Firefox has a bug.
Yeah, but so HTML imports is it was overlapping with what the ES6 imports, so maybe they will consolidate on that. But in the end, so some features or some ideas are still there. They have been implemented by all the browsers. It's just like the community of like. So if you would want to implement something that can be used cross, like in React and in Angular, well, not Polymer, but the technologies under Polymer can be used, and they might be a good way. And there are efforts to do this kind of like fancier video players or something that can go. But yeah, it's like in the end, it's like a tussles inside Google there. Like,
yeah, I think just a final message here. Or are there more questions? Or
is there still room for one question? I think you have something.
Well, yeah, thanks. Maybe after all this talk, it's not much of a question, but maybe a challenge to you. That can you imagine any maybe post-apocalyptic scenario where you would rather use Polymer other than any other choice?
I would use Polymer instead of Project Query, I guess.
Yeah. Well, that's a point.
No, that was all I had.
Yeah, so instead of jQuery. But I think one final message here is that it's good to know, maybe not worth to use thinking that we have really good, really stable frameworks out there. But things like that, for example, if Google invested in that, there's a purpose in that. We had a small story here, but it shows we learn also from failures, we learn from errors, we learn from things that don't work that well as well. So we learned a lot in those months working with Polymer from the mistakes. Yeah, thank you.
Thanks, guys.
Thank you. And of course, your super cool honorary Web Dev and Sausages hats. Make sure you get a sticker. There you go. Thanks for coming down here, guys. Or up here, I should say. Yeah. Okay. Again, a short little break. 5 minutes or so. Our last presentation. And then the big quiz. Next year, you guys give the presentation you wanted to give.
No, but it was very nice. Thanks for the invitation. I was a little bit. I don't want to do that in the beginning, you know. But I think it's more for sharing the experience.
Yeah. So stay in touch. We'll organize the wines, beer.
Yeah. That's good. Beer tasting should be.
Vodka. I don't know, something. Tasting.
Yeah. We'll be around for a while.
Ehkä se on enemmän kuulossa.
Mikko.
I guess you're just planning to share papers, or how? Yeah.
So just after each round?
Yeah, I think that's sufficient. With the team name. Team name and
do they have to write who's in it? Or?
No, I guess just the team name is enough. I guess no one will cheat. I really don't know, but
so is
that's like how they do it on Wapice.
So let's do that after each round. I'll try the papers and then so we can already be grading. You don't have to grade everything.
Yeah, I guess unless we want to give scores between the rounds. Yeah,
maybe that's too hard.
Yeah, probably easier.
We could just say who's the leader and how many points they have. If we're best.
Yeah, that's yeah. No need to ask anything.
Viljami, whenever you're ready, just it's all yours. When people look ready.
Does this thing work? Oh, cool. Okay, let's get started. Let's do another depressing presentation. So as you might see from the title, it's not a happy one, this one as well. So sorry about that. So first because thanks for introducing me, by the way. So, yeah. So my name's Viljami, or Antti Viljami, as I call myself in the social medias. So I'm kind of known for being an anti-digitalist guy, for mostly my Twitter contributions to Koodi Klinikka stuff as well. But yeah, I've been called a Forbes featured hacker for some reason. I got featured by a blog on Forbes for exposing a Chrome bug, basically. But that's just ridiculous, doesn't make any sense to me. But what I do for my day job is APIs, a lot of DevOps stuff and some open source advocacy stuff at Futurist. But yeah, enough about me. So what makes me able to talk about APIs is that I've been working with them quite a bit. So right now I'm working on microservices for Kesko, and it's a bit of a work in progress still. So if you're seeing bad experience from Kesko, don't blame us yet. because we haven't quite gotten the stuff done. But basically what that is, it's just hiding hard business problems behind simple APIs, right? It's so simple and easy. All right, so also I've been doing some volunteering work at API Ops, which is a nice community of API related stuff as well. And I've been doing some live stream stuff, live coding APIs from scratch. So if you want to catch that stuff, that's me there not knowing what I'm doing. But yeah, like 4-hour, 5-hour live streams of just me coding an API from scratch. But cool, so why should we even talk about bad APIs? Well, I guess that was the other presentation where we were talking about a bad framework, a kind of a failed thing. Because we learn, and also it's fun and makes me feel better about myself, because I do bad stuff as well. Right. But honestly, it just helps you avoid those mistakes that other people have made. So, stories. Just a disclaimer, I'm not talking about like my clients here. You can't like point to any API that this is GuestGuard, this is some other client that I've been working on. Hopefully, I've tried to obfuscate that as much as I can. But yeah, just a disclaimer for that. So the client says we have these APIs for third-party services, but we would like you to build new ones on top of those, which is a bit suspicious already, right? Because you already have APIs. Why do you need more? Why do you need APIs on top of APIs? It can't be that bad. It's probably just integration stuff. Some orchestration logic, because it's microservices. All right. So let's look at the first one they want us to do. And it's SOAP. We love SOAP, don't we? Everybody loves SOAP. So yeah, I'm not a big fan, but at least I know SOAP. I've been doing SOAP stuff before. And absolutely no documentation available anywhere. But everybody knows SOAP APIs are self-documenting, right? That's good. Right, so that's the first problem I want to talk about. So missing or incomplete documentation, that's a huge fail when talking about APIs. You want to have documentation. You should at least have like a README where you can have like a few example requests that you can run. That would be nice to kind of just get started. Well, it's SOAP, so we have the WSDL. So we should be able to use it anyway. Even if you don't have any documentation, we have the description of the API. Well, we can't see the WSDL. So it doesn't look like a SOAP API. So that's the second problem we had. It turns out the API is actually behind a gateway product that doesn't fully support SOAPs. So we're not going to get WSDL from the gateway. So what's the solution? We'll just email you the WSDL file. Right. Because APIs never change. That's good. Yeah, well, it's not optimal, but it's okay. We can still work with that. We can just change it when we need to. So, time to set up a SOAP client and use the WSDL to explore it. That's the cool thing about definitions like with SOAP or Swagger or those kind of standards, because you can actually have like clients that are able to look at the API and explore them automatically. Cool. I'm going to use SOAP UI. Oh no, that doesn't look good. So it turns out my SOAP client doesn't work with the WSDL file they sent me, or any other client that I could find, which is a bit weird. So looking into it, it turns out they had the error message that actually quite useful. It said target namespace already in use by another schema, and it turns out there are two schemas with the same target namespace, and that's in the SOAP spec that you can't do that, but for some reason this API did. And so easy solution, let's just merge them manually because we have the WSDL file now. We can just go and like open up Vim and do it. It's fine. Not optimal but workable. So finally my SOAP client is set up and I can start exploring the API. So let's try this method called lookupMember. Looks like a pretty basic getter. So SOAP UI gives me this example request that I should be able to do. And guess what happens when I try? Oh good, 200k. But not quite what I expected, right? Well, so null pointer exception. That's not very useful for me. I try to get something, and I get a null pointer exception, and I can't access the code of the underlying backend. So, couple of problems there. You probably shouldn't return 200 OK when you have a null pointer exception. The second problem is that as an API consumer, null pointer exceptions or other things that are related to your programming environment aren't very useful. I didn't even know that you were using Java. I didn't want to know, I didn't need to. So we had to ask for help. All right, what that says. So we emailed them, asked them to help us. So it took 3 days, about 6 emails to get to the person who knows about that API. This was a third-party vendor, so that wasn't like our client. But we had to go through our client and then get to the vendor, and then we were put in contact with that person from the vendor that was able to give us an explanation of why is this happening. And they were able to give us, oh yeah, well, that's a problem. It's quite hard to get help. But they gave us an example and it worked. So the problem was that only the root element supports the namespacing that SOAP UI gave us. So they defined example requests for us that didn't work. So they defined that we should be using namespaces here, but turns out they can't do that. Fun. But now it works. So we get something. We get a person with a UUID and name, email, birth date. Yeah. So next thing to do, we want to try a setter. So we're doing like basic CRUD stuff, creating and updating things. And it worked. This was the first time we tried something and it worked the first time. This is so cool. However, the problem with this response is that now if I want to know if my setter worked, because I'm setting stuff, now I have to go back and use a getter to get it again, to just check that my setter is going to work. So that's kind of annoying. But, well, it's called a chatty API, and it's kind of just annoying to do that sort of thing. Just too much traffic. You don't want to do that. But fine. Again, we can just live with that. So moving on. And we know, this was not specified, by the way, but we know that there shouldn't be 2 people in this database, in this service, with the same email. So just to try it, what error we're going to get, because we don't have any documentation yet. So we want to try what happens, so we can handle it in our code. So I use a setter, we send a duplicate, and 200 OK again. Well, this is a pattern that we've learned from this API. But couple of things wrong here. Can anybody spot what you would do differently? Right, again with the Java errors, like SOAP service fault is not something that's very useful to me. It is like machine readable though, so that's good. But then, like, that's Swedish, isn't it? If I remember my high school Swedish, that's Swedish. Bad error messages. So just generally don't do Swedish. US English, a lot better. So would be nice to have machine readable error messages so that you can handle those easily in your consumer code. But yeah, pakkoruotsi, I mean, that was cool. For the first time in my career, I got to use Swedish. It's not for nothing, guys. Okay, let's try one more. So, get member by UUID. So another getter, something quite simple. This time we're just going to get a member instead of just using ID. We're going to use the UUID. Should be simple. Seems to work. Wow, cool. Can anybody spot a problem with this? Last time I gave this talk, somebody actually did, which was surprising. It's not clear. Well, here's the thing. That was wrapped in result, and the other method I used was wrapped in return. So you can imagine how many hours I spent debugging why my code is not working. But yeah, there's just, it's a minor annoyance, but still, don't know why. Inconsistent API responses. You want to have your responses be similar to each other at least. Okay, time to look another API. Remember, we're doing adding APIs on top of other APIs, and the client has a lot of third-party APIs and services they want us to build on top of. Well, they say it's a REST API, and well, everybody knows if your client says you're going to work with a REST API, it's never going to be a REST API. They think it is, but it's not. And it turns out they have Swagger documentation, and that's kind of cool. That's kind of a new thing, isn't it? And that's, you want to have that. And I can even use like Swagger UI to explore the, well, this is the pet store. Let's call it the pet store API. But yeah, I can have a look at different endpoints. I can get example requests here. I can even try those requests. That's awesome. Like, it can't be this easy. Well, let's explore. Let's do get pet 1. Okay, okay. Looks good, looks good. But I don't really like the data structure. Like, well, that's just a bad model. If you, well, why would you do this if you can just do this? That's 3 lines. This is how many lines? And it's the exact same information. There's no benefit to doing this, at least in this instance. That's just annoying. So moving on. Try a setter. So we're going to post a new pet. And what's funny is the post method actually gives us this structure. They don't demand us to use the weird other thing, but that's fine. I like it this way. 200 OK. Status queued. So we get a UUID. So what happened to Garfield? Garfield is some queue, in some queue somewhere, just waiting. They gave him a number. He got, well, we don't know which ID, because we know IDs are like numbers. They're not UUIDs here. It's not supposed to be UUIDs. So, looking at the Swagger documentation, we see there's something called the pet queue. So we're going to go look for Garfield in the pet queue, because we have the UUID he got. So, let's see what happened to Garfield. He's cute. Thanks. So this is the async way to do things. So we're just going to have to poll this queue, wait for Garfield to go through the queue, and then... Well, it makes sense if you have something like a really big workload that you have to do, but this is a setter. Like, I don't care. I'm adding a pet in a database. It shouldn't be this hard. Well, it wasn't a pet. It was actually, in that API, it was a person, but still. Shouldn't be that difficult. Well, now I need to poll this endpoint until the insert has finished. So, a couple of minutes of polling later, job done. We still get the UID, but this time we get a result, and we get a pet ID, which was what we were looking for. Now again, it would be nice to see the pet here. Now we have to do one more request. And we get this annoying data structure, but it works though. I'm quite happy with this. So imagine putting this in our API. Now we have to handle this as well. But at least it worked. So, well, I'm not going to go to why this had to be as async. There was really no reason for that. It was just, that's the way the developer of that system liked to do things. But the last thing we want to do is we want to list some pets. And you remember the ID, by the way. We got 50,232. So I'm guessing it's about 50k pets in the data store. So let's do get pets. Okay, it's doing something for quite a while. Nothing's happening. Gateway error. Connection to backend timed out. Curious. So I have a hunch that this might have something to do with the number of pets. Yeah, 50k. So it turns out if you don't specify a limit, it'll just try to give you all the pets from the API. And it takes a while in this database. And we crashed the API, by the way. We had to call our client and tell them, sorry, the developer environment is now down. Can you do something about that? Yeah. So another problem, you should have default pagination, because most data stores have more than 10 items in general. Okay, that was the story. So, quite quickly now, what did we learn? We learned why our client wanted us to abstract these APIs. And we learned the world is full of shitty APIs. And I want you not to make any more, please. And here's how. Please have examples. Provide executable examples users can type directly into their terminals to see working API calls. That's a good practice. Get a README and try to run the example code. You can't go wrong with that. You want to describe your API using standards. Now, both of these APIs actually did use standards, which is good. But I've seen loads of APIs that don't. So GraphQL, Swagger, well, I'm not sure if RMAL and Blueprint are really good to use anymore, because Swagger kind of won the API definition wars now. But yeah. And even WSDL if you're a SOAP kind of person. Java people here. Yeah. So, this we saw as well, return appropriate HTTP status code. That makes it a lot easier to handle errors in my code. See Wikipedia for that. It's not too hard. You want to generate useful errors and not Swedish errors. Or Finnish, for that matter. You want to avoid making chatty APIs, so a good thing to ask yourself is, does your API serve its purpose in as few requests as possible? I think that's a good way to design APIs. Try to make them easy to use and try to make them fast to use as well. Keep your API responses consistent, really important as well. There are standards here. Models, you don't have to overcomplicate things if you don't, you don't have to. Even if your database looks different, you want the API to be as simple as possible just for the sake of the users. And there's something called schema.org that tells you how to structure certain models, like most common models like addresses or what else is there? I don't know. URLs, that sort of thing. So if you use like coordinates or anything, there are standards that you can look up. So pagination, we saw that. It's probably not a good idea to provide endpoints that will crash your service. Unless that's something you want to do. You generally not. If you don't test it though, why not? And I think this is the most important one. Just if you're making an API, make sure it's easy to get help, because we're going to make mistakes. But the thing is that you want to have somebody that can help the person using your API. Should be you, preferably, but even if not, include some contact in the API itself. And yes, developers are people too. You're building an API for a human. So how do I then make a good API? Well, just avoid those things and read. Here's some suggested reading that I'm going to leave here. And if you guys have any questions, I'd love to take them. That's
Questions?
Go ahead.
You didn't happen to have any solution for the async problem?
Yeah.
How to avoid the polling?
Right.
I know you can, of course, provide a notification to some URL, but then the caller would have to set up his own HTTP server, which is a pain too.
Yeah, so you can't really avoid async. Sometimes you just have to do that. Especially when you're using HTTP as the transport for your APIs. But the thing is that use async only when necessary. In this instance, the reason I was kind of annoyed with it was a setter, and they could have just responded that, okay, we have received your data, and this is how the data looks to us. We didn't really care what happens after that, so fire and forget.
What's your opinion about that? Would you prefer having to poll or having to set up an HTTP server to get a notification?
I haven't actually thought about that. I would like to minimize the amount of requests, so I would say polling is usually, well, not preferable, but I do see how it makes it simpler as well for the developer, so I don't really know.
This describes a lot like my life.
Yeah. Thanks.
Yes,
Peer support.
But how can you? Do you have advice how you can make your customer create better APIs? Like how to make them
Right.
follow some
Magic. Yeah.
I don't know.
Because, well, your clients are going to buy their APIs from somebody else, and just make them buy from somebody who's going to.
No, they're making their themselves.
Oh, good.
Yes.
Good. So maybe in that instance, you would go talk with the developers at your client and talk about what you want with the APIs.
Yeah.
Just talk with them.
Or you can ask Viljami to come to talk for money.
That's also
for your
very
client.
true.
Okay,
Hi.
I think the 7 emails in 3 days sounded familiar, but those were low figures, I think.
Yeah, it's in the low end.
Sometimes
That's
it's
true.
more, yeah.
That's true. But in this instance,
I think in more general sense, it's often about like no one's responsibility area. Like the client works with companies A and B, and they do their stuff, like almost up to the point of having examples or something. And then who will pay for the shit job?
Yeah.
Then the one who has to work with the API or in the integration or whatever. Maybe it's just something that the party that says, okay, we'll just use their API, has to always like put some extra hours to them. So this was not actually a question, but if you have something to comment, then I'd like to hear.
So I'd like to remind you that, like, who are we building APIs for? And I'm talking about APIs from like a product perspective. So the product's going to build APIs for the client, right? Because the client wants to use them for something. And the client's going to have developers who are humans. So I would say you should remember that APIs are supposed to serve the consumer always. And the consumer is usually a human.
Can you tell an example of a crappy API endpoint you have made?
I have made, right. So I made quite a lot of, like, in the past, I think. I've made a lot of shitty PHP stuff that didn't have any specification. It was just post something to this and then something will happen and I won't tell you what. And that's a common thing I would do. Didn't know better back then, and now we have Swagger, now we have REST API specification and that sort of thing. So I think things are moving forward as we understand what microservices are for and what benefits they give us. It's not just using it in some software.
Is there still some questions? Yeah, one.
Okay.
So,
hey,
about the error messages. So, I don't know what's the exact question, but what do you think is the good kind of like a middle road between telling enough about what went wrong and not then exposing kind of like a security information that can be used kind of like the wrong way?
Yeah, so I definitely don't advocate for like just passing error messages through your libraries to the end API consumer. That doesn't make sense to me. So like with the different definitions, you would usually define how the payload looks, how it's supposed to work, and how it's supposed to respond. So in the case of like I'm going to send a payload that's not correct, like in the first example I sent the wrong payload to the API. So it's actually quite easy to use some library that's going to enforce that definition. So you would have something before it actually goes to the API to look at the payload, does this format looks correctly? And that's going to handle 90% of all your problems already. And then just try to handle errors in your code. Like, you're probably going to see some errors while you develop stuff, and you want to know that, okay, so this is a common thing that's probably going to happen. So this is the kind of error we're going to return. But that's it, really. Just use the HTTP status message, because usually it already helps quite a bit just to give the whether it's the user problem, so a 400 error message or a 500 error message. That's already quite enough information. So as a consumer, I would know if it's my fault or if it's the API's fault that something's gone wrong.
Thank you.
Okay. Still one.
Cool. Hi.
What do you think about response sizes? Because now when we have G chip and everything, that is it good to provide like these monolithic responses instead of like responses that can be split to like smaller chunks?
Yeah.
I once made this application which communicated with this Rata API, which tells like train information and departures and such. And I asked the API that, please API, could you tell me like the trains that leave from Helsinki station from 30 minutes from now on, and it gave me 10,000 rows.
Yeah.
And what do you think about it?
So, right. So that's a totally really common problem, and when we have like open APIs, they tend to be like Excel files, so just dumps of, I don't know, JSON or CSV, something like that, and you get the entire data set. And I think that's wrong. That's definitely wrong. So the API should be such that you can ask for the information that you want and just not get everything all the time. But then there's also the question of if you actually want a large data set, so how do you actually go ahead and do that? And that actually depends on who's your consumer. So if it's a browser, what you actually can't do is you can't make the browser wait for like a gigabyte of data, usually. So you have to stream that in some way. So you have to use some socket or something. So it really depends. But yes, there should be ways to get even large amounts of data from APIs. And well, a good pattern that we've seen in our microservices, for example, is just get an endpoint that asks for an export, for example. So I define that, okay, I want to export to this S3 bucket, for example. And then what happens in the background is, well, it's the async thing again. Then I can ask if this is done now. So that's one way of doing it, if you have a really large data set.
Yeah, thanks.
Sure.
Hey, thank
Awesome.
you.
Cheers.
Yeah.
Great. Thank you.
Here's your hat, dude.
Oh, nice.
Yeah.
Cool.
Cool. So for those of you who are sticking around for the quiz, it's just going to be a laid back kind of thing. So just kind of have fun and socialize while we do the quiz. We'll start in about 5 minutes or so. You can have a team up to 6 members. I'm not going to check actually, but like don't have a 20-person team because then you'll just crush it. If you're a solo kind of person, that's cool. You can do it alone. You'll need a piece of paper and a pen, and you'll probably want to be in the vicinity of your teammates and maybe not too close to the others if that's at all possible, because of course you'll want to keep your answers secret. We'll start in about 5 minutes or so. What? 6. Max was 6. Give or take one. Yeah. Yeah, papers and pencils are on the table there, and we have like an official judge, Mikko Mattilainen, who's somewhere around here who will be responsible for checking your answers. You need to be sober. This is going to be difficult work for you. 3 sections. After each section, listen, the instructions are important because there's pride at stake and there are prizes at stake. So you want to get this right. So first section is general knowledge. It's pretty short. You write down your answers. You turn that in at the end of that round, right? So at the end of each round, turn in your piece of paper with the name of your team. Don't forget the name of your team or we have no idea who you are. So every team has to come up with a name. Those of you who go to pub quizzes, this is pretty usual stuff. But yeah, so I'm coming up with a name and write your answers in clear, readable handwriting. All right? Mikko's got to be able to read it. And I think that's it. And then we finish, we'll add it all up and we'll tell you who's the grand prize winner. Okay? Are you ready? Should we start? Okay. Mikko, you have a special honorary place here. Okay, don't hide. Okay, get a beer. Here's your hat. By the way, the second round is a speed round, right? So you're going to get to see the questions for a small amount of time. So somebody in your team better be paying attention. This first round, though, I'll give you time to talk and think about it. There's only, I think, 5 or 6 questions. All right, let's get started. Round 1. Oh, yeah. It goes without saying, right? Guys, computers? You guys got your computers over there. Don't Google stuff. That's not cool. We all know that's not cool. Here we go. General knowledge. Question 1. You're going to start easy. What does PHP stand for? 1 point. No, you don't tell me. You write it down. Leo, go ahead if you want, because my stuff's not working, so. Mikko, you look kind of lonely there. It's better to be in it playing, isn't it? Yeah. Okay, the first one was easy. We're going to go to the next one in a few seconds here. Okay, here comes the second one. If you're not sure of your answer, then just write down the question and come back to it. Second one. What company originally developed MS-DOS? Actually, it was first known as 86-DOS. IBM, Washington Digital Research, Seattle Computer Products, or Microsoft? Multiple choice. All right, are we ready? Question 3. Oh, there's some bad English there. I thought I fixed that. So, who is the inventor of the language Smalltalk? That should say it. Who primarily invented Smalltalk? It's bad English, but yeah, who invented Smalltalk? Okay, next question, number 4. Who is this? Okay, next question. What is a monoid in the category of endofunctors? Sorry, that's a fun one. General knowledge, completely general. This is like everybody knows this stuff. Notice this is 2 points. Okay, I think this is our last general knowledge, so-called general knowledge question. This has a bonus attached to it. Who has this is general knowledge, come on. Who has the highest reputation on Stack Overflow? And if you're really like a Stack Overflow geek, what is his score with like give or take a little? Okay, if you have got no answers right so far, don't worry, go home. No, I'm just kidding. You're not the only one. There are people here who like have no clue what these are. So. Yeah. So write down your last answer and please turn in your paper to Mikko, who's that guy in the front at the table. Pretend like a. Well, actually, I have my phone. What do you mean? No, I just keep going to the next question. To Mikko over there. At the end. Yeah, Mikko is sweating as he Googles for the answers. The next section is called code recognition. And as I said, I'm going to give you like a brief look. So here's how this works. All you have to do is write down the name of the language, right? So I'm going to show you code in different languages, and you have to write down its name. And I think there's one or two with bonuses. Yeah, just write down JavaScript 11 times, and one of them will be right, maybe. Okay, starting the timer. Ready, go. You guys in the back might have to move closer. I don't know how well you can see these. And time is almost up. Next. Okay, and number 3. Okay, that one's done. On to the next. Number 4. This has a bonus. Write down the language, and you get a 1 point bonus if you actually give the version of this language. I'm going to give you a little extra for this one. All right, that's time. Number 5. All right, that was easy, right? 6. Everybody looks really unsure. Seconds. Okay, that's the end of number 6. Moving on to number 7. It's my personal favorite. Okay. A few more seconds and we move on to 8. Number 8. Okay, moving on. You're going to kick yourselves later when you find out what that is. Number 9. This has a bonus as well. What is the name of this sequence? Okay, moving on. I think you want to go past this one. Number 10. I don't think anybody's going to get this. Okay, moving on. Oh, that was it. That was the 10. I'm going to just like flip through them one more time, just like really quickly. So if you want to venture one more guess, here's your chance. Number 1. Number 2. Mikko, the points. You want to notice the points? Number 3. You got it? Okay. Number 3. Number 4. Number 5. Number 6, number 7, number 8, number 9, number 10. Okay, we'll have a little break, a couple minutes. Turn in your papers to Mikko again.
Here's the score from first round. Who's the winner? A consensus. That's so far. If you want to give like if you can make anything out of that, just ask if you. Okay. Let's do.
Okay, I can give you an update after the first round. The leader is no consensus, a consensusta, clearly in the lead. And then we have like a lot of people on their tail. But yeah, they actually did really well. They got 4 plus bonus. Yeah, who are those guys? Where are you? Where are the leaders? Ah, these guys. Okay. Okay. This last round is different. So there are fewer items, but you actually have to think now. So I'm going to show you a piece of code and ask you a question about it, and you actually have to try to figure out, for example, what the code does. All right. Are you ready? So I'm going to give you some time for these. All right. Here's the first one. This is a two-parter. What is this called? So this has a name, this technique, and what does it do? Okay, that was the easiest of the bunch. Let's move on. Are you ready? Was that enough time? Okay, nobody says anything, so yeah. Okay. What will this print when run? You've all been waiting for this language, right? Well, not really, but C#. So what will happen when you run this little piece of code? Just a quick note, I went and got a beer from the refrigerator, and I haven't noticed that there's like crap loads of drinks left in there. I don't know what's going to happen to them, so if you didn't notice, if you want a beer, please, there's a refrigerator by the kitchen there, and it's full of drinks. All right, I'm going to give you like max a minute here, half a minute. We'll move on. All right, let's move on. Number 3. Oh yeah, this is a good one. So you can answer this in 2 ways. You can just like kind of write what does it do, or if you prefer, if that's hard to explain, then you could just like give a little example of what it would look like in your terminal.
That's gonna help.
Vaniljejäätelöä, kanelikeksin muruja, mansikkahilloa ja kermavaahtoa. Sunday Deluxe. Sundayt sekä kaikki kesän pilleimmät jälkkärit. Mäkkäristä.
Leo. Okay. Raise your hand if you are just writing down the answer. Are you ready? Can we continue? That means you're done, or you're not done. Okay. All right. This is a 3-parter. And some of you have been waiting all night for finally this one. Okay. So 3 things. Each one, PHP. Each one a point. So each of these, just tell what that is going to do. And the second one's obviously multiple choice. And write down your answers. It is JavaScript. It's not a secret, in case you didn't know. Okay, while you're considering the answers, I'll give you a status update after round 2. It's pretty exciting. So, A, consensus, no consensus, still in the lead, but only by a little bit. They have 12 plus points. By the way, this is really an accomplishment. Everybody got some points, so that's already great. In second place and doing pretty well is Us by the Window. I hope that's not Us by the Window of the computers. No, it's Us by the Window over there. Okay. And just a funny bit of trivia, 3 of you have status codes as your names, so that last talk was very influential. We have 503, 404, and 200 OKO. All right, so how are we doing? Do you need more time with these? If you need more time, say more time. Okay, nobody says more time, so we're going to go on. All right, I'm sorry. This is Python, and it's like a one-liner. There's no indentation here. It just, of course, didn't fit in the slide. Yeah, so again, what does this print when run? It's a little bit smaller, so you might have to, again, come in close to make sure you see the code. Just give these your best guess if you don't really know what's going on, because like good creative guesses, you know, you might get like a half of a bonus point or something. Okay. Some more time. Okay, I'll give you a little more time. Yeah, this needs time. No problem. I'll get another beer. All right, put down your pens, stop doing the math. Oh, these guys are working so hard. Sure. If it looks like you've understood the code, we're happy. All right, you can have part of the team continue to work on that one, and I'll show you the next one. Okay, there's this one and there's one more, so there's only two left. And this is Kotlin. Is anybody who uses Kotlin? Yeah, we just got a great blog post over there about Kotlin. All right, but I don't think you have to have used it to kind of figure out maybe what this does. Are we ready to move on, or you want a little more time? Move on. Okay. So this is a last question, and it's a doozy. This is a language called NIM. Does anybody here know NIM? That's what I thought. What does this print when run? Since this is the last question, I won't actually stop. You can just look at this forever, or you can turn in your paper to Miko. So when you finish, just bring your slip to Miko, and he'll do the final checking, and we'll announce the grand champion when everybody's turned in their slip. Is there any team that hasn't turned in their paper yet? Okay, so we'll wait.
It's okay, I'm not gonna get this done anytime soon.
All right. So-called general knowledge. All right. There's actually two possible answers. The original name was personal homepage, but it's actually a recursive name, PHP : hypertext preprocessor. We might give you a plus. Yeah. Good job. Okay. Yeah. It's called Seattle Computer Products before it became Microsoft. Yeah, Alan Kay invented Smalltalk. There are some other people involved, but he's the best known guy. No one. All right, that was maybe a dumb question. Nobody got it. Or it was such a good question. Yeah. How many of you knew the Lisp guy? He's also famous for many other things, artificial intelligence and John McCarthy. It's kind of a meme, according to Miko anyways. All right, this is great. One of you put down STD. We're going to give you a plus for that because it was so funny, like mononucleosis, STD. Yeah. But it's a monad is the answer. And yeah, quite a few of you got that. All right. Did anybody get, how many people got the John Skeet as the, like? Maybe one or two. Okay. Yeah, John Skeet is legendary. He's a C# guy. And it's like answered half of all C# questions. Antti, did you know John Skeet? No. Okay, and then let's go to the code recognition. So, let's not that fast. So the funny thing is, like, some of you had all the right languages, but in the wrong order. I'm afraid we can't give you credit. But PHP, WebAssembly. WebAssembly, of course, is a favorite topic of ours. Less, which is compiles to CSS. Fortran, and the bonus was Fortran 77. Somebody actually got both of those. Good job. The fifth one was Swift. You got it? Yeah? 6 is Velocity, the templating language. Number 7 was Erlang. Some of you put Elixir, which, well, Elixir is built on Erlang, but CoffeeScript. Did you guys get CoffeeScript? Yeah, good job. Almost JavaScript, but not really. Better than JavaScript. At least it used to be better than JavaScript. I love CoffeeScript, but now it's not cool anymore. It's lost its coolness factor. Haskell and the Fibonacci. Somebody got that too. And the last one, did anybody get VimScript? Did Miko? Did anybody get VimScript? No, yeah, okay. That was a doozy. Okay, code understanding. From what I've seen so far, you guys did pretty well in this. Sorry, this is like I just copied from Stack Overflow. It's called a clear fix. If you're a front-end guy, you should know that. And it forces the content after the floats or the container containing the floats to render below it, so it keeps them from overlapping. Common problem. Okay. The answer to the C#, the first one will print location is null. The second one will print precisely this date. Okay, the third one, so basically it gives you what's in your directory, the read write, the name. So this is actually, I just ran this in my terminal, and then it replaces all the vowels with U's. So Richard Van Camps becomes Rutchard von Kamp, and node modules becomes nudu modulus. Yeah. All right. JavaScript. First one was undefined, not nothing. Some of you put nothing. JavaScript always gives you something, just something crazy, undefined. Second one was 15. And the last one was a whole lot of zeros, floating point math. And like if you're missing a zero or something, we'll be forgiving, but as long as you were close. Okay. The fifth one, if you used your kind of like good sense, you probably could have figured it out. You didn't have to know the exact numbers as long as we understood that you understood what those mean. So it gives you an array, and each array has a label, a string of what it is, byte, kilobyte, megabyte. Donald Trump doesn't actually matter. The fact that it's Donald Trump, of course, you're going to get the next level, which is what, terabyte, I think? So, all right, that's number 5. Kotlin, this wasn't so hard. Some of you guys, a lot of you got this one. Oh, right, okay. The judge says yes, so I'll go with that. Yes. And what does this print? It turns out it prints nothing. At compile time, it prints hello world. So this was like totally a trick one. How many of you put it prints hello world? Yeah. Maybe we'll give you a half point for that, because at least I believe so, yeah. But there's actually an online nim compiler. Oh, was there no exclamation mark? Okay, maybe I added that. Yeah, so we'll give you without. But it was at compile time. So that's it. So Mikko's hard at work. It's pretty hard to like grade these. So give us a few minutes and we'll announce the big winner and we'll tell you your scores. And if you don't agree with any of the answers, it's Mikko's fault. Okay, they were my questions. You can blame me. Oh, God. So, the good thing is that there are like clear differences between the top places. So, let's start from third place. Third place, this is pretty good. They had 15 and 2 pluses, so that's like 16. We know. Where's we know? Yeah, good job. Wow, all the way in the back. Yay. All right. I think that's our sponsor team. Is that right? Sort of, okay. Second place was Us by the Window. Yeah, good job, Us by the Window. You guys had 17 plus 3 pluses. I'm really surprised how many of these you guys got. All right. And the clear winner, not by a small margin, was a consensus. No consensus. Congratulations. And many of you will remember Teemu from our WebAssembly challenge when he confused us all with his WebAssembly mastery. So, did we applaud them? Let's applaud, yeah. Good job. And we have a prize for you. If you would like to come up to the front, I'll present you with our prize. So, here's a sticker. No. So, first of all, this is web dev and sausages. And we're not joking about the sausages. So, this is a really little, you guys can have a barbecue together. Okay. And you can cook some sausages. Yeah. Plenty of sausages. And then finally, your team has to decide who was the star of the team, who contributed the most, and you can give that guy one of these prized web dev and sausages hats. Okay.
We know who contributed the most, but the problem is that all the other guys are from Go4.
Okay. You guys can decide among yourselves. If you want to fight about it, take it outside. That's all I have to say. Okay. Thank you again. You can give feedback about this quiz if you hated it by email. But that pretty much concludes the evening. Thank you again for coming. I hope we see all of you again in a couple of months for the next Web Dev and Sausages. As always, we're really happy if a potential sponsor comes or a potential speaker. So if you have any ideas, I will send out an email and ask you for feedback and ideas. But basically now just enjoy yourselves and party as long as you like. Well, maybe not as long as you like. Is there a limit? Okay, so 11 max, and then you go to Apina and continue there. All right, so thanks, everybody. Thank you, Mikko. And if you want to see your exact score, you can come and look. We have the official tallies here if your team is curious. What was your team?
Team 4.
This one?
This.
So you guys got 10 plus.
So we are not the last.
No, not anywhere close. What was your team? Zero code 4. You guys got 7.5 plus 3 pluses. Woo! Did you get the C# one? Probably not.
Kolme A, ei ole keskustelua.